Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit. Today we're going to be talking about the discriminant, which is a tool for helping us know how many real roots a quadratic equation has. Let's start with a little bit of review for quadratics. So a quadratic equation, ax squared plus bx plus c equals 0. This has roots, solutions, right? These mean the same thing, of the following. So we have negative b plus or minus square root of b squared minus 4ac all over 2a. You can prove this formula using completing the square. I'll link the previous Thursday tidbit on completing the square below. But this is just a general way of, okay, we want to solve this equation without thinking too much. We plug it into this formula, and this gives us the roots in that case. Now, the whole idea of what we're going to be talking about today is this square root portion. Right? You might worry a little bit here. Well, what happens if we have a negative number? We can't take the square root of a negative number, at least over real numbers and things like that. If we have plus or minus 0, this stays the same, so we don't really have two different solutions. And all of those very basic ideas are exactly the discriminant. So, in more details here then, right, for a quadratic equation, ax squared plus bx plus c equals 0. As mentioned, this portion underneath that square root, b squared minus 4ac, is what we're going to be calling the discriminant. And just so we have a symbol for this, this is oftentimes described with the symbol of delta. So delta is b squared minus 4ac, the discriminant, and it helps us know how many real roots an equation has. So we have three cases. When this delta is greater than 0, when that square root portion is greater than 0, no troubles, plus or minus the square root of the discriminant, we have two real roots. And in particular, these two real roots are different. So when we say two real roots there, we really mean there are two different real roots in that case. If this discriminant is 0, we have plus or minus 0, so there's one root. And if you kind of learn a little bit more about quadratics, it will make sense why you might want to call this a double root. So you kind of think of it as a single root, but it's repeated twice in that case. And the third scenario is delta less than 0. Here we have no real roots. This is when you would be taking the square root of a negative number, right, which can be problematic, and so there are no real roots in that case. Now, if you want to know, for example, you're graphing something, you want to check real quick, does it cross the axis, right? You can use the discriminant on quadratic equations to find out how many roots it has pretty easily. But, right, let's look at a different example as well to see how the discriminant can be powerful. So the more interesting type of question you can answer with the discriminant is something like this. So we're asking here, for what values of m does this equation that involves x, right? So we're solving for x, but it has this other constant m in it. And we want to know what values of m will give us two different real roots of this equation. Right, so even if you tried kind of doing other methods, right, this m is unknown, so that's kind of problematic a little bit. But this is exactly where the discriminant comes into play, right? We want the discriminant, we want delta to be greater than 0 in this case, because we need to have two different real roots. So we look at that delta being greater than 0 for this problem. So, do we know what delta is? Well, delta is b squared, right, minus 4ac. So let me just write this out here. And so b squared is negative 6 squared. So we have negative 6 squared minus 4 times a, which is 1, times c, which is m. So this is our m. So our delta actually becomes 36 minus 4m in this case. But what do we want here, right? We want this equation to be greater than 0, right? So 36 minus 4m needs to be greater than 0 in that case. So you solve this equation, right? You can add the 4m to both sides, divide by 4m. I don't want to spend too much time solving the equation in this case. But if you solve that inequality, you end up with m being less than 9. So as long as m is less than 9, this original equation will have two different real roots. And so this is a nice way you can kind of apply that discriminant to help you out without solving the equation or anything. Figure out how many real roots it has, and even the range of m in this case, where this equation has two different real roots here. So thank you guys all for watching. Check back each Thursday for a new Thursday math tidbit. And hopefully I'll see everybody on the ZIML site for practice as well. Goodbye.